Good afternoon, Year 10, and welcome to our lesson on Monday, the 11th of January. We're going to do this lesson as a pre-recorded one. So I'm here on Sunday, just recording this video. It's going to have a starter and the answers, and then an explanation of today's topic. And then I've set you some work to do, which will be on Teams. So quick five, as always, are on the screen now, so pause this video and have a go at them. Okay, and now for the answers. So a few things that we've looked at recently in these questions and a few things we haven't looked at for a while. So write the number 5,267 correct to the nearest hundred. So the hundredths digit is the 2. There we go, so we can see the next digit along is a 6, which is 5 or more, so we need to round the 2 up to a 3, and then 0, so it's 5,300. And write down the value of the 2 in this number, it's 200. Remember, you can't just write hundreds, you have to write 200. Pink one here, what is 10% of 70? Well, 10% is 1/10, and a tenth of 70 is 7. And 5% of 60, well, 10% would be 6, which means that 5% would be 3. We're using the fact that 5% is half of 10%. Red one over here, convert 5 metres into centimetres. Well, a centimetre is 1/100th of a metre, so in 5 metres there will be 500 centimetres. And convert 2 kilometres into metres. Well, a kilo means 1,000, just like kilograms, so kilometre is 1,000 metres, so 2 kilometres is 2,000 metres. The orange one, the nth term for this sequence, well, it's going up by 5 each time. So we did this with Mr. Madison last half term, which means it's going to be a 5n sequence. Now 5n would represent the 5 times table. This one you can see the 5 times table would go 5, 10, 15, 20, 25, which means that the sequence in the question is 1 bigger, so it's 5n plus 1. And the green one is to add these fractions together. We've got quarters and sevenths, so our common denominator is going to be 28ths. So the first fraction we need to times the denominator by 7, which means we must also times the numerator by 7. So 3/4 is equivalent to 21 over 28. And the second fraction, we've times the denominator by 4, so we need to also times the numerator by 4. And we see that 5/7 is equivalent to 20 out of 28. So then our answer is going to be 41 out of 28. I'm happy if you leave your answer like that. It doesn't simplify. You could also turn it into a mixed number, which would be 1 whole 1 and 13/28. Okay, so hopefully those went okay, and if not, I hope the explanation made sense. We're going to talk about maths today. So what we're going to do is we're going to look at factors to start with. So title is factors and prime factors. So you can do this in your book. Okay, so the first thing we're going to do is we're going to think about what are the factors, just the first part, factors of a number. So if we pick a number, say 8, let me get off straight lines. So what are the factors of 8? So a factor of a number is a whole number that will, in this case, divide 8 exactly without remainder. So what can you divide 8 by? Well, you can divide any number by 1, and if you were to divide 8 by 1, you would get an answer of 8. I always like to do factors in pairs like this, and you could also divide 8 by 2. In fact, all even numbers will have 2 as a factor, and if we do 8 divided by 2, the answer is 4. And that means that if we did 8 divided by 4, the answer would be 2. So these factors come as pairs, and I've colour-coded them like that. You see that factors will always be less than or equal to the number that you've got. So if we just go through the ones we've missed, 3 is not a factor of 8 because 8 divided by 3 would have a remainder. The same with 5, the same with 6, the same with 7. So 8 has 4 factors. So the first thing we're going to do is just a quick task. So I've got a table like this, and I'd just like you to copy this into your books and fill it in. Okay, so we've just looked at the first one together, which is 8. So I'm just going to add that to my table. So there we go. So 8 had factors 1, 2, 4, and 8. And I'm going to write them in order from smallest to biggest. So the number of factors, how many factors has it got? It's got 4 factors. Okay, I'll do one more with you. So let's do a number like 12. So factors of 12. So I'll start with my little sort of like a spider diagram type thing. So what are the factors of 12? Well, remember we said for any whole number, it will have 1 as a factor, and 12 divided by 1 is 12. And that means 12 divided by 12 will be 1. So next pair, well, 12 is an even number. So that means that 2 will be a factor. 12 divided by 2 is 6. So 6 is a factor, and 12 divided by 6 would be 2. Are there any other factors? Well, 12 can also be divided by 3 without remainder. So 3 is a factor, and 12 divided by 3 is 4. So 4 is a factor. And if we just check 1, 2, 3, 4, 5, 12 cannot be divided by 5 without remainder, nor can it be divided by 7, 8, 9, 10 or 11. So we found them all. So for 12 we've got 1, 2, 3, 4, 6 and 12. 12 has quite a lot of factors. It has 6 factors. So what I would like you to do is I would like you to just fill in this table and see what you can come up with from 1 to 20, please. So pause the video, have a go at filling it in. If you need to do factor bugs like this, you can draw them, but I think for lots of these questions you will not need to do factor bugs, you'll just be able to do it in your head. Okay, brilliant. Well, we'll check these ones really quickly so you can check you got the same answers. So if I just go through and do the factors first, so the number 1 has only a single factor, 2, 1 and 2, 3, 1 and 3, 4 has 1, 2 and 4. Interestingly, although 4 is 2 times 2, 2 is only a single factor, 5 is 1 and 5, 6 is 1, 2, 3 and 6, 7 is 1 and 7, 9 is 1, 3 and 9, 10 is 1, 2, 5 and 10, 11 is 1 and 11, 13 is 1 and 13, 14 is 1, 2, 7 and 14, 15 is 1, 3, 5 and 15, 16 is 1, 2, 4, 8 and 16, 17 is just 1 and 17, 18 is 1, 2, 3, 6, 9 and 18. Check that you didn't miss any of those out. 19 is just 1 and 19, and 20 is 1, 2, 4, 5, 10 and 20. So So if we just fill in the number of factors, then you can see that we've got 1, 2, 2, 3, 2, 4, 2, 4 we'd already done, 3, 4, 2, 6, 2, 4, 4, 5, 2, 6, 2, 6. Okay, great. So we filled that in. The next thing to do then is to define what is a prime number. So a prime number, the definition is really simple. A prime number is a whole number which has exactly 2 factors. So if we look down the third column of our table, all the numbers with 2 factors are going to be prime numbers. So 2, 3, 5, 7, 11, 13, and if we just scroll down, 17 and 19. So that's it. Importantly, the number 1 is not a prime number because the number 1 only has 1 factor. So we're just going to write that definition down quickly. So prime numbers have exactly 2 factors. There we go. And there's also another interesting thing, which is you'll see that most of these are even numbers, but there are a few odd numbers that come up. Here is an odd number, here, here, and here. So what do the numbers 1, 4, 9, and 16 have in common? Those are all square numbers. So another little point is that square numbers have an odd number of factors. And the reason why they have an odd number of factors is because if we go back to our little factor bugs, usually the factors come in pairs, but when you look at a number like 16, because it would be 4 times 4, you only put that factor once and not twice. Okay, right, so now there's one more thing to do, quite a quick thing and something we've done before, which is prime factorisation. So we'll go on to why this is useful in our lesson tomorrow, I think it is, which we'll do as a live lesson. But for now, we'll just do the sort of step behind it. So there's a really important rule in maths. It's called the fundamental theorem of arithmetic, and it states that every positive integer has a unique prime factorisation. And I'll show you what that means. So what we'll do, we'll find, for example, the prime factorisation. We'll do a couple of examples. Find the prime factorisation of 28. Okay, so you would have done this before. So this is the sort of thing where we can say, right, 28, I need to factorise it into prime. So I need to find prime factors of 28. So the best way to do this is we do it with our sort of factor tree. So you might think of 2 numbers that times to make 28, say 2 and 14. Now if you've got a prime number, 2 is prime, we figured that out earlier, you can circle it. If your number is not prime, like 14, then it's called a composite number, so you can divide it again. So 14 is 2 times 7. Now 2 is prime and 7 is prime, so we're finished. So then what we would say is we would say that 28 can be written as 2 times 2 times 7, and this is what we call a product of prime factors. or the prime factorisation. Okay, and that's it. And the fundamental theorem of arithmetic states that this product of prime factors will be unique for each positive integer. So we'll do a couple more of these because they're quite quick, and then you've got some questions to practice. So example 2 is going to be find the prime factorisation of 45. Okay, so same again, 45. Now 45 is not an even number, so we don't want to divide it by 2. However, it does end in a 5, and that means it will have 5 as a factor. How many 5s do we need to make 45? 9. Now 5 is prime. You can look back at your table. 9 is not prime. 9 is a composite number. So 9 is 3 times 3. And 3 is prime. So we can say that 45 is equal to 3 times 3 times 5. I always write the numbers in order from smallest to biggest. Right, and we'll do one more. We'll do a slightly bigger number. So example number 3, find the prime factorisation of 180. So exactly the same method again. We're just going to gradually divide 180. So what could we do? Well, it's even, so you could divide it by 2, but you might also even spot that it ends in a 0. What does that mean if it ends in a 0? That it's divisible by 10. So we could write it as 10 times 18. Now, neither of these are prime. 10 is 2 times 5, and 18 could be 2 times 9 or 3 times 6. I'll go for 2 times 9. 2 is prime, 5 is prime, 2 is prime, 9 is not prime, so we go again, and 9 is 3 times 3, and these are prime. So what can we say then for 180? We can say that 180 is 2 times 2. 2 is the smallest prime, so always start with that. Next would be 3, so 3 times 3, there's 2 3s, and then finally there's a 5. So 180 is 2 times 2 times 3 times 3 times 5. Right, as I said, we'll look at why this is useful tomorrow, but for now we're just going to practice this, a little bit of hopefully not too tricky maths. You're going to have an assignment on Teams, which I want you to do now. It should come live at 2:45 p.m. So you should have got it now or in the last few minutes. And it will be a form for you to fill in. So it's 10 questions. Some of them involve typing answers. Some of them are multiple choice. So read them carefully. You might have to log in with your school login, or it might just do it through Teams for you automatically. To be honest, I don't know how it will work because this is the first time I've used a form like this at all. So let me know if you've got any problems accessing it. I will be online. Hopefully it works okay. And we will have a live lesson next time. Good luck with the task.